Lesson 24, I will determine whether a whole number is a multiple of another number. So write your name at the top, and let's see that the directions say, for each of the following, time yourself for 1 minute, see how many multiples you can write. So I hope that you learned from your Zern lesson that whenever you are counting by multiples or you are writing multiples, you're actually counting by that number. So if I say write the multiples of 5, then you would say 5, 10, 15, 20. But notice that this says write the multiples of 5 starting from 100. So you're going to count by 5s starting at 100. So go ahead and write 100 here, but don't write anything else. I'm going to time you for 1 minute, and then I'm going to tell you when to stop. So wait until I say go. Ready, set, go. Okay, stop. All right, so let's see what you wrote. All right, so I don't know how far you got, but it'd be pretty obvious whether or not you were doing it correctly or not, because you would say 105, 110, 115, 120, 125, 130, etc. So how far did you get? Did you get to 200? Did you get to 300? Well, good for you. All right, so now you're going to start by writing the multiples of 4 starting at 20. So we're going to count by 4s, but we're going to start at 20. So again, you have a whole minute. Wait until I say go. All right, ready, set, go. Okay, stop. All right, so let's see how you did. All right, so we started at 20, we were counting by 4s. So that would be 24, 28, 32, 36, 40. Now you did this in your Zern lesson. So in your Zern lesson, they were pointing out to you a pattern in the ones place. So once you figured out the pattern, it became pretty easy. Because if you notice, the ones just continue to repeat over and over and over and over. So I don't know, how far did you get? Did you get to 100? Did you get to 140? Did you notice any other patterns? Let's see, I see 2, 2, 2, 3, 3, 4, 4, 4, 5, 5, and then look, 6, 6. So in the tens place, you'll have 3 of the same, and then it'll go to 2, and then it goes back to 3, so that's another pattern. All right, so now we're going to write the multiples of 6 starting from 36. So you're going to count by 6s, but you're going to start for 36. And let's see if you find any patterns when counting by 6s. So again, I'm going to time you for 1 minute. On your mark, get set, go. right, so time is up. All right, so let's see how you did. So counting by sixes, starting at 36, so you would say 36, 42, 48, 54, 60, 66, 72, 78, 84, 90, 96, 102, 108. Are you seeing any patterns? Let's see. Examine the ones place with me for a minute. Let's look at what's happening in the ones. So we have 6, 2, 8, 4, 0. 6, 2, 8, 4, 0. 6, 2, 8. Keep going. Does that pattern continue all the way through? How far did you get? Did you get to 200? Good. So all of these are multiples. When you're counting by a number, you are saying the multiples of a number. All right, so now we're going to list the numbers that have 24 as a multiple. So what that means are, if I was counting by numbers, what numbers would I say 24? Like if I was counting by ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, would I eventually say 24? Yes. So 1 is a multiple of 24. If I counted by twos, would I say 24? Yes. I would say 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. What if I was counting by threes? 3, 6, 9, 12, 15, 18, 21, 24. Yes. What if I was counting by fours? Yes. I want you to keep going and think of all the numbers that you can, that when you're counting by them, you would say 24. Well, could you think of any more? Well, I thought to myself, when I count by fives, I don't say 24, but what about sixes? 6, 12, 18, 24? Yep. What about when I count by sevens? 7, 14, 21, 28. Nope, went right over it. What about when I count by eights? Yes. What about when I count by nines? No. Tens? No. So eventually I got to 12s, and the answer was yes. And the last one was 24. What do you notice about these numbers? What if you did this? 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. And 4 times 6 is 24. These are actually what of 24? These are actually factors of 24. Because if I can multiply something times 2 to get 24, then 2 or 24 is a multiple of 2. It gets kind of confusing sometimes for fourth graders to tell the difference between a multiple and a factor. So we'll have to work on that to make sure that we get that correct. Use mental math, division, or the associative property to solve. Use scratch paper if you like. Is 12 a multiple of 4? Is 12 a multiple of 4? What do you think? Well, let's count by fours. 4, 8, 12. So is 12 a multiple of 4? Yes. Is 4 a factor of 12? Is there anything times 4 that equals 12? Well, yes. 4 times 3 equals 12. So, yes, 4 is a factor of 12. Is 42 a multiple of 8? So let's count by 8s. 8, 16, 24, 32, 40, 48. Did we say 42? So no, 42 is not a multiple of 8. Is 8 a factor of 42? No, because nothing times 8 equals 42. 8 times 5 is 40, and 8 times 6 is 48. So there's nothing times 8 that equals 42. So is 84 a multiple of 6? So we could count by 6s to 84, but it might be faster just to divide. So let's go ahead and take 64 and divide it by, 84 and divide it by 6, excuse me. Go ahead and pause the video and see if you get a remainder when you take 84 and divide it by 6, and let's see what you get. Okay, so when I divided 84 by 6, this is what I got. I got 14 with the remainder of 0. So is 84 a multiple of 6? Well, the answer is yes. So if I counted by 6 is far enough, I would say 84. Is 6 a factor of 84? Yes, because 6 times 14 equals 84. So I hope you're starting to see this relationship here. So if 4 is a factor of 12, then 12 is a multiple of 4. If 8 is not a factor of 42, then 42 is not a multiple of 8. Can a prime number be a multiple of any other number except itself? Remember what a prime number is? A prime number is a number that only has exactly two factors. So like think of the number 17, okay? 17 has two factors. It has 17 and it has 1. So can 17 be a multiple of any other number except itself? So what do you think? Well, I think yes, because it can be a multiple of 1. Of course, all numbers are a multiple of 1, but that would be it. All right, so now we're going to need some crayons or some colored pencils. If you don't have any crayons or colored pencils, you can come and see me, but you're going to need a red, you're going to need a green, and you're going to need a blue. If you don't have any of these colors, you can come and see me, and I'll be glad to dig out some colored pencils for you. So the first thing it says is circle in red the multiples of 2. When a number is a multiple of 2, what are the possible values for the 1 digit? So the first thing I want you to do is I want you to go through and I want you to circle with your red crayon or your red colored pencil all the multiples of 2. So you're skip counting by 2s and you're going through and you're circling all the multiples of 2. When you get finished, come back and press play. Okay, I bet you started to notice really quickly that there was a pattern, right? You could go right straight down the rows. So let's go back down here to this question that it asked us. It said, when a number is a multiple of 2, what are the possible values for the ones digit? Well, look at your ones digit. All of your ones digits were either 2, 4, 6, 8, or 0. So if a number has a 2, 4, 6, 8, or a 0 in the ones place, what kind of number is it? Well, that would be an even number, right? So now we're going to shade in green the multiples of 3. Okay, so you're going to need your green crayon or your green marker. Okay, I'm going to go with the highlighter here to make it so that it doesn't shade it where you can't see it. All right, so we're going to go with green, and we're going to shade in all the multiples of 3, okay? So you're going to take your green crayon, and you're going to shade in all the multiples of 3. All right, so I'm going to pause the video. Whenever you get finished, press play. Okay, so did you notice a pattern? I bet yours looks a little bit nicer than mine. Mine looks a little bit sloppy, but did you start to notice a pattern? I'm pretty sure that we did this in our Zern lesson too, but did you notice how the diagonal pattern that you started to see? Now, it says, what do you notice about the sum of the digits? Okay, choose one. All right, so let's choose 81. I'm going to choose 81. So 81, let's go back to a pen here. 81, so the digits are 8 and 1, so that would equal 9. All right, choose another. All right, so let's choose 96. So 96, so I've got 9 plus 6 equals 15. So what do you notice about 9 and 15? Well, they're odd. That's what I notice. So the sum of the digits are odd. Did you notice, did you pick two different numbers and were the sum of your digits odd too? All right, we've got one more. Now we're going to use blue and we're going to circle the multiples of 5. Okay, and then it said when a number is a multiple of 5, what are the possible values for the ones digit? So this shouldn't take you very long. So go ahead and choose your blue and then go through and circle all the multiples of 5 and then we'll come back. Okay, so whenever we were doing the multiples of 5, that was pretty quick, and I'm sure you noticed that pattern. So our question asked us here, whenever a number is a multiple of 5, what are the possible values of the ones digit? Well, that would be 0 or 5. Draw an X over the multiples of 10. What do all the multiples of 10 have in common? All right, so go ahead and put your X over all the multiples of 10, and let's come back. All right, so what did you notice about all of the multiples of 10? Well, they all end in 0, right? So, your task is to remember the difference between a factor and a multiple. And we're going to talk about this in class, about how we can tell the difference, how we can keep these two straight in our head, factors and multiples.